Hello there and welcome back to my new video. So in this video I am going to finally show you how to support multiple screen sizes in Android application with Jetpack Compose. Now with Jetpack Compose it's a lot easier to support multiple screen sizes and adapt your layout to fit basically each and every device out there. Now for this video specifically I have prepared already one project which I'm going to showcase here. But before we get straight into the code, let me first showcase you how this application will look like on different devices. So for example, here I am running two different devices, a smartphone and a tablet as well. Now both of those devices are currently in a portrait mode and you can already see the difference. Now in this mobile device we can see that each one of those items in our lazy column is created in a row. So here we have one row and then we have this image and then those elements. However, on tablet devices we can see a different layout structure. So here we are not using actually this row, instead we are placing those elements in a column. So first we are displaying here that image, and then below this image we can see those two text elements and also those icons. So of course this project is just for the demonstration purposes, and I have added the logic to actually display those icons only if we have a certain height available on our device. So that's why we don't see those icons right here, even though we could have added those icons in our mobile device as well. Nevertheless, the next thing you might have noticed here is the number of lines for this description text. So in our smartphone device, in a portrait mode, we can see only those 4 lines of text. However, on a tablet devices, in a portrait mode, we can see a lot more lines of text here. Okay, now let me just switch this tablet in a landscape mode. So now when we switch that to a landscape mode, we're going to see a difference. So now the layout structure of those items on our tablet and smartphone device are the same. So here we have a row and here we have a row as well. Now of course, since here we have some more space to show our elements, we have decided to show those icons and increase the maximum line for this description text as well. And another difference between those two devices is that on a tablet we can see those text elements with increased font size. Now we can also change this application to a landscape mode as well on our smartphone device, and here you will see that now we have increased basically the size or the font size of those two text elements, and the size of this image has been increased as well. So bottom line, we were able to support all modes like a portrait and a landscape mode on both of those devices, and also our layout is able to change its structure dynamically when we have a bigger height on our device, like we can see here on this tablet. Okay, so in this case we have a bigger height to show our items, and that's why I have chose to show those elements inside a column rather than a row. Alright, so now that you have seen how this multiple screen support looks like on a tablet and a mobile device, now I'm going to open up this project which I have already prepared for this video, and then I'm going to explain how all of that is actually configured. So the first Kotlin file which I want to show you here is called WindowSize. By the way, don't worry, the source code of this project will be available in the video description, so you can check it out. Anyhow, here we have one data class called WindowSize, and this WindowSize contains two variables or two properties, width and height. And each one of those property contains this window type, which is an enum class that I have created. So this window type can have 3 different constants basically: compact, medium or expanded. Now we don't want to work with the exact values of our screen width and height. Instead we want to have a little bit more convenient method to handle our screen size based on those 3 constants of our window type enum class. So for example, this compact constant will be used for our smartphone devices in a portrait mode. This medium will be used for our smartphone devices as well, but in a landscape mode, where we have a little bit more width, for example. And this expanded will be used to represent the tablets, or basically the highest possible width and height of our devices. Now down below at the end I have created two different functions which will basically calculate this window type which I have just shown you. Now, depending on the width and the height of our device, we will assign a different window type. So for example, for our screen width, if our width is less than 600, then we're going to assign a window type compact. Otherwise, if the width is less than 840, then the window type will be medium. And in else case, when that value is greater than 840, then the type will be expanded. The same applies with the screen height, with just one difference. Of course, that difference is the actual value of the height. Okay, so let me just scroll right here. So we have created one function, composable function named the remember window size. And here we are using a local configuration current, so we can calculate and remember our actual screen width in a DP. And that value is passed directly to those two functions, get screen width and get screen height. And the result of those two functions will be stored inside our WindowSize data class, which we have already created. Now let's proceed to our main activity. So here in our main activity we are calling this remember Windows size function, and then from this variable we can actually access those two properties to decide how we want to arrange our content on a different screen sizes. Then here I'm also using a nav controller, so this is just for demonstration purposes, even though we actually don't need a nav controller in this case. Anyhow, we are passing that window, or actually window size, to our nav graph, and then we are passing that window size to basically each and every composable screen we have. Now in this case we have only one, so home screen. There we go, so this is our home screen, and our home screen is just displaying all those items which I have prepared to show from our home view model. And those items are displayed in a lazy column. Now here, as you can see in our home view model, I have just created a logic to randomly generate some hard-coded values for the image, ID, title, description, and those icons. So this is basically the same data that I have used in my previous video about box with the constraints. So if you haven't watched that video, I highly suggest you to do that, because you're going to learn about one important composable function as well. Anyhow, in our home screen, we are basically using this lazy column to display all those items. And as you can see, this is our custom item which I have created. So this custom item contains two parameters: the actual data which we are passing to that adaptable item, and the actual window size. So depending on that window size, we are going to configure and structure our layout differently, okay? So we are using basically this window size, which we have passed from our main activity, to decide how we want to arrange our elements on different screens. Now the first thing you see here is a variable named max lines, and here I have written the logic to return either 4 or 10 for a maximum lines. Now if the width of our window or our screen is compact, then we are going to use a 4 as a maximum lines we want to display for our description text, okay? Like you can see here. So here the maximum lines for this second text is 4. However, on our tablet, that number is increased. In this case, the maximum number of max lines is 10. So below that, here, as you can see, I have one when block, and in this case, now I'm checking the height. So why I'm checking here the height? Well, because you can see that in our portrait mode on our tablet, I'm displaying those items in a column rather than inside a row. And because of that, I will need to access the actual height of my screen to see whether I can display those items in a column or inside a row. Now here, as you can see, when our window type is expanded, that means that we are using actually a device that does have a very large screen height, like our tablet in this case, and in that case I'm calling this column content, which is displaying those elements in a column rather than a row. So let's open up that column content. As you can see, it contains the actual data, then the window size, and the maximum lines which we have passed just above. Now also this column or this column content contains one more variable named show icons. So this is actually a boolean value which will decide whether to display those icons in each and every item or not. Now that calculation is also done by using this window size. So here we are checking this case whether a window size height is actually of a type of expanded. So when the height of our screen is largest, like we have in our tablet, then in that case we want to show those icons. Otherwise, if our window size height is not of a type of expanded, if it's less than expanded, then those icons will not be visible, because down below we have just created a simple if block. So if this value is true, then we are displaying those icons, otherwise we are just hiding them or not displaying them. And here of course you can see some other elements like this title, the spacer and the description text as well. Here for the font size, as you can see, depending on which device we are using and depending on how many width and height we have in each and every device, we can display a different font size as well. So for example, in our smartphone, we can see that our text here does not have a large font. However, on our tablet, that font is increased. So basically, based on that window type which we are passing all the way from our main activity, we can decide basically each and every state of our app. So we can decide whether to increase or decrease our font, then to decide how many lines of text we want to display as well, by using these max lines which we have declared up in our composable hierarchy, so right here. So of course the source code of this project will be available for you to download, so don't worry about that. Anyhow, now you have seen how easy it is to support multiple screen sizes on our Android using Jetpack Compose and this window type. So here in this case I have added only 3 different constants for our window type, but of course you can add more of them, and you can of course add here one more when case. But of course that depends on your application requirements. In most cases those 3 constants like a compact, medium and expanded will be just enough. Now, if you have any questions related to this topic, feel free to comment down below, and I will gladly answer to all your questions. Also, be sure to comment down below and like this video if you find it helpful, of course, and see you in the next one.